Hi everyone, welcome back to Lulumath. This video is on function notation, and this is video number 2 of 2 videos on this. The first video is available as well at lulumath.com and the Lulumath YouTube channel if you want to check it out before this one. So some background knowledge that you'll need to know. You'll need to know what a function is. You'll need to understand function notation part 1, which is the video I was just talking about. And you need to know how to expand and simplify polynomials because we're going to look at function notation, but really heavy on the algebra. So speaking of algebra, some inputs are algebraic, resulting in algebraic outputs as well. So in our first video, all of our inputs were numerical. They were actual numbers, and when you plugged in your numbers, you got numerical answers. Now we're going to plug in algebraic inputs with variables, and we're going to get outputs that have variables in them as well. So here we are given that g of x is equal to 3x plus 5, and h of x is equal to negative 2x squared minus 4x plus 1. So the first thing we want to find is g of 3a. So here we have 3a as our input. So what this means is every time I see an x in the function that is defined by g, or in this function right here, I'm going to plug in 3a as my input, or as my x value. So if g of x equals 3x plus 5, I'm going to say g of 3a is going to be equal to 3, and then instead of this x here, I'm going to replace it with the 3a, and then I'm just going to add the 5. So this will be g of 3a, and now I'm just going to multiply. So 3 times 3a is 9a, and then I'm just going to copy down this plus 5. Now these are not like terms, so that means that this is my final simplified answer. Notice how our output is 9a plus 5, and our output is also algebraic. Now in our next example, we've got h of 5x. So this time we're going to be using our h function, which is this one right here, and our input is 5x. So every time we see an x, we're going to replace it with 5x. Now this is a little bit tricky because we'll see x. Why should we replace it with something that has a different kind of x in it? See here, when we had x, we replaced it with 3a. It's the exact same idea. So here we know h of x is equal to negative 2x squared minus 4x plus 1. Every time I see an x, 5x goes in instead. So I'm going to copy down this negative 2, and then I'm going to fill in 5x instead of x here, and then that's getting squared minus 4 multiplied by 5x again, and then plus 1. Again, this is a little bit confusing for people because they see x and they're like, well, why do I put in a 5x? But that's because this is h of 5x instead of h of x. So I pull the x out and I put in the 5x. I substitute the 5x instead. Now I just use order of operations to evaluate, and then I'll go from there. So h of 5x is equal to negative 2, and then according to order of operations, I should do my exponents first. So 5x, when I square it, becomes 25x squared. Because I square the 5, I get 25. I square the x, and I get x squared. And then I'm just going to copy the rest of it down because I don't see any more exponents to deal with. Now I'm going to go ahead and do my multiplication. So here, negative 2 times 25x squared is negative 50x squared. Negative 4 times 5x is negative 20x. And then the 1 just tags along. And this is my final answer because there are no like terms that I can put together. So I'm done. All right, in our next problem, we are still using the function h of x. So we'll still use this function that we see here. And this time, our full input is this x plus 3. Every time I see an x, I'm going to replace it with my input of x plus 3. So it goes in here, and here, and here. I'm going to expand this x plus 3 quantity squared. So I'm going to just copy down this negative 2. And if you need help on the expansion, make sure you check the video out on how to multiply a binomial by a binomial, specifically a binomial by itself. I'm not going to spend the time doing this, but just a reminder, it might be easier to just write this out as x plus 3 times x plus 3, and you can either FOIL, or you can distribute, or you can use the box method. Doing all of that out results in x squared plus 6x plus 9. Just a reminder that this is not x squared plus 9 because you have to distribute through to everybody. I'm going to copy down the rest of my problem exactly how I see it because I don't have to do any more squaring. Now I can go ahead and do my multiplication. So I will distribute this -2 through to everybody. So -2 times x squared is -2x squared, -2 times 6x is -12x, and -2 times 9 is -18. I will also distribute this -4 to this x. I get -4x, and then -4 to the 3 gives me -12, and then I just copy down the +1. Last thing I need to do is just collect my like terms and then I'm good to go. So I can see this -2x squared, nothing is like it, so I will copy that down. But I have -12x and -4x are like each other, so when I put those together, I get -16x. And then lastly, I have -18 minus 12 gives me -30, plus 1 is -29. So this here, we can say that h of x plus 3 is equal to all of this stuff that we see here. All right, in our last example, we are going to use the h function and the g function. So we're going to do h of x minus 1. So we're going to use this function here for this piece over here, with x minus 1 being our input. And then we're going to use the g function that we have here with 4x squared plus 7 as our input. So we have h of x and g of x written in front of us. So here what I'm going to do is, in my h of x function, every time I see an x, I'm going to replace it with this x minus 1. So this will say -2 multiplied by x minus 1 squared minus 4 times x minus 1, and then I'll have this plus 1 at the end. So this whole piece right here is what I just did right here. Then I have a minus sign in between them. Then I have a minus sign in between them. And now I'm going to use g of x, but every time I see an x, I'm going to replace it with this 4x squared plus 7. Now I need to open up my brackets because I'm subtracting all of g of x. So I'm going to open up my brackets, then I'm going to write in here this 3, and I'm going to replace the x with this 4x squared plus 7. So notice I have brackets within brackets, and then I'm just going to add 5, and then I will close my original set of brackets. And here, technically, you could use brackets here. You don't need it, but you can have it. So this piece right here is this part right here. All right, now let's go ahead and expand. So there's nothing I can do with this -2, so I'm just going to copy it down. And then this x minus 1 quantity squared, remember, that means x minus 1 times x minus 1. I'm not going to spend the time expanding this. So it's x squared minus 2x plus 1, and then minus 4 multiplied by x minus 1. By the way, even though I'm not spending the time expanding this, if you have any questions, please feel free to reach out. We are more than happy to help you out at any point in time. And then I'm going to say plus 1. Again, the brackets are not necessary, but totally fine if you put them in. The next set of brackets, however, are necessary. And I don't need to expand a binomial, so I'm just going to distribute this 3 through. So 3 times 4x squared is 12x squared, and then 3 times 7 is positive 21, and then I'm just going to copy down this plus 5 that we have here. All right, so now let's go ahead and simplify each set of brackets. So I'm going to distribute this -2 through to everybody in here, and then I'm going to distribute this -4 through to everybody in here. So when I distribute the -2, I get -2x squared plus 4x minus 2. And then when I distribute the -4 through, I get -4x plus 4, and then I will write plus 1. And then close this bracket. And oops, that bracket went missing. Minus, now there's nothing to expand in this next set of brackets, but we will put the 21 and the 5 together. So 21 plus 5 is 26. So I get 12x squared plus 26. Now I can distribute the negative through here, or I can simplify each set of brackets and then distribute. It doesn't matter. So I'm actually going to do both just to make things go by quicker. So if you see here, in my first set of brackets, I have nothing to distribute. So I'm just going to collect my like terms and remove the brackets because they're not really necessary. So this negative 2x squared, nothing is like it. So I'm just going to copy it down. This 4x is like this negative 4x, and 4x minus 4x is 0. They cancel each other out, so I don't need them anymore. This negative 2 is like this 4. Negative 2 plus 4 is positive 2, plus 1 is positive 3. Then I'm going to distribute this negative through. So when I distribute the negative through to the first term here, I get a negative 12x squared. And then when I distribute it through to the second term here, I get 26. So I'm going to write down minus 26. Now I'm just going to collect some like terms. So negative 2x squared is like negative 12x squared. And when I put them together, I get negative 14x squared. And then 3 is like negative 26. Put those together, I get negative 23. And there's nothing else that is alike. So this is my final answer. All right, that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be useful, please make sure to share with others and subscribe. Thank you, and we'll catch you next time. Bye.